So with that, I'd like to introduce today's speaker. Today's speaker is Jeff Turner. He's going to speak on Bitcoin stacks and large language models. And he's going to cover a number of topics here. His bio says he's been a Bitcoiner since 2011. I'm sure we'll hear more about that. And he's had executive positions at various organizations, Novell and Cisco Systems, amongst two of them. He's currently, as I mentioned, teaching a course at Chapman with Professor Kurtz, which, again, we're delighted to see that come out of this organization's network. So, Jeff, let me turn it over to you.
My name is Jeff Turner. I've been into Bitcoin for quite a while. I've also run a software consultancy. Just tell you a little bit about me. I've been programming for more than 40 years. I'm a command line guy using Vim for most of my work. But I started out on an HP 85 writing basic programs. And I essentially, my father was very impressed because I was able, over a Christmas vacation, to write a full blackjack program with a graphical interface on the machine. And this was pretty early on, but I didn't want to do that. I actually wanted to become a doctor. And started that way in school and then turned around and wound up getting a computer engineering degree. I then went on to Novell and Cisco Systems, where I was an executive and basically made my way up the executive stacks. And then about 20 years ago, I discovered something that I'd been involved with since the early 90s, and that was to figure out how to overcome the problem of network traffic being fractal. Basically, what this means is if you take traffic input A and traffic input B, you blend the two together as they're flowing across the network, they'll be non-deterministic. You won't be able to have a linear relationship between those two things. And anyway, about 20 years ago, I came across this paper from a guy named, actually, Thomas Kurtz, who's at University of Wisconsin mathematician. And lo and behold, I said, okay, I've got to go start my own startup company. Because in essence, what we had done is come up with a way, if you will, to change the intersections on the internet from going from like traffic lights where you'd have a center square and a set of stoplights to using a roundabout system and getting deterministic throughput through these so-called intersections on the internet. That resulted in me being on the opposite side of something called net neutrality, which was an agenda pushed by a number of big tech companies. This is almost 20 years ago. And I was pushing for creating diamond lanes and truck lanes on the internet. And anyway, lo and behold, I wound up where I am today after going back into doing a lot of coding work the last 10 years because we spent about $4 million in Washington, D.C. fighting these issues with my startup company. So I got into crypto actually before Bitcoin was even out there. We had worked up for that same company that I was talking about a settlement model by which we could settle the internet transactions. We had this idea of doing internet cash. This is before Satoshi Nakamoto's famous 2008 Bitcoin paper. And so I got deeply into these consensus models and various work. Then I wound up at a company called Exodus last year and the year before as CTO, Chief Technology Officer. Exodus is one of the big software wallet makers in the crypto space. So right now, as Dan said, I'm teaching a course at Chapman as an adjunct professor that's focused on Bitcoin and using AI with large language models to create a set of different type of applications, which we'll get into in just a second. But I thought I should start with an obligatory joke. I asked ChatGPT to write a joke for me on Bitcoin and AI. I'm not sure it's that funny, but so I asked it, I said, write a joke about Bitcoin, AI, and coding, and said, sure, here's a joke for you. Why did the Bitcoin miner hire an AI programmer? Because they wanted to create a cryptocurrency that could code itself. Not too bad. And then I asked it to make the joke edgier, and it refused. It said, due to safety and alignment issues, it would not make the joke any more edgy. So anyway, that's my background. What I am not a machine learning expert. I know the basics of these systems. I am not a deep learning expert, which actually that visual up there is something I grabbed off the internet a while back, which I think has a pretty good description of all the different algorithms and how the hyperparameters are set within these things. It's a good roadmap, if you will, for at least I reference it frequently to look at, to understand how these different systems are actually being developed. I don't have a deep understanding of those hyperparameters, backpropagation, or stochastic gradient descent, and I'm not currently a known researcher in this space. What I am is a teacher who's been trying to figure out how these things are going to impact our software engineering lives. And that's been my focus and emphasis with the class this semester too, with the students. What I find most interesting about AIs is how they'll change the way we have our work experience as software engineers. So that's really my focus and my focus in this presentation too. So what I thought I should do is take us through this outline, go through how LLMs perform coding tasks for us, what the various tool sets that are out there, what is going on in academia and in the research world for determining best practices and figuring out how we can be more effective as software engineers using these things. I'll get into a little bit of the importance of some of the things that we've discovered that are important in using these things and how they should be developed. And some opportunities that we thought was when I first started teaching the class at the beginning of the semester, that we thought we had that we ultimately didn't. And then the implications on open source, give you guys some sense of some use cases and some things that we've discovered as we've gone through this. And then, as I mentioned, what impact on software engineering practices, software engineers, and some of the future work opportunities. What I should first probably do is ask all of you, how many have used AI to code? Oh, okay, much larger than I was expecting, okay. And I assume you're using, I'll get into this in just a second, but I'm assuming that you're using just straight up web browsers or Copilot for the time being. I'd like to propose some perhaps deeper and more productive ways that you might be able to use these things as we've discovered. In my personal experience, I've got a software consultancy, and we're easily 3 times more productive than we were a year ago using these tools. So I'm actively encouraging students to use this. I'm actively encouraging the people that work with me and that work for me to use them as well. I may be in a unique position in that a lot of people who are working in companies, and we'll get into this in just a second, are not able due to licensing and legal issues. Okay, so this is the way I think about large language models and coding. These LLMs, in my mind, are basically large compression engines that have a context or a focus. And in that context or focus, there's, if you will, a center, and all these things, really, all the LLMs really do are predictive text machines. They figure out what's the next thing, most likely thing to come out after the previous string of things in that context window. They can they can perform badly. They can produce very, very bad code for you. They can produce code that is completely off the mark. And so therefore, it becomes very important to create feedback loops with the systems as you're using them. And that's one of the big things that we've discovered is we can vastly improve the quality of the code that we create from these simply by telling the system that it's wrong, or having the system describe some attributes of the code and such that we can then use to get it back into focus, so to speak. So my view is that the more articulate and specific that you are when you're using these tools, the better off you'll be with both the quality and the quality and productivity that you'll gain from using them. So there's a whole set of tools out there. We've been investigating these for the better part of the last year. You've got CodeLlama, ChatGPT, GitHub Copilot. My students and my consultancy has been using a tool called Aider. Has anybody heard of Aider before or seen it? Okay, a couple. Yeah, Aider, we think that hands down, Aider has been one of the best assistants, especially in helping the students complete their assignments this semester. And by the way, what I'm basically relating to you is giving you a survey or a review of a lot of what's happened this semester at Chapman teaching this Bitcoin AI class. And I'm giving you, I guess, 1 month before the school semester ends, where we're kind of at, and I'll have even a bigger update in a few more weeks. And at the end of the talk, there's a link to our GitHub page for the class, so you can see all the lecture notes and everything else that we've produced. So if you have interest in that, there might be some nice things, especially if I can talk you into using Aider before the end of this. There's also a set of academic reviews and some research work, but it's pretty few. There's few and far between papers out there or a lot of research. These are some of the research abstracts that I've come across that I found helpful. I particularly like that first one with Dan Bonet and Neil Perry. Dan Bonet is a famous cryptographer up at Stanford who's pretty well known in the space, and the conclusion of that paper is that we're actually finding that a lot of the code that's being written is less secure as a result of using these LLMs. So you still have to have that discernment and judgment when you're writing code with these things. And they've come up with actually a more formal mechanism to go through and assist people who are using these. That formal mechanism, I'm going to give you a little variation on what that is and where I think we're going to move forward, and not only my class, but I'll probably be doing with my software consultancy with this as well. And it involves taking a much more structured approach when you're writing the code. But this is a big area of opportunity for researchers, for academics, and such. And it's a very interesting space because years ago, we had agile software development that came in, I guess, basically in the 90s. And it really transformed the industry and the way that software engineers work together. You had this notion of scrums and stand-ups, and the processes were very different. And then things like continuous integration became a mainstay, I guess about 15 years ago or so. And so did the development of better practices with which we would do our DevOps. And that, I think, is all going to be transformed in the next several years due to AI as well. So it's a very interesting time to be an engineer. Or a software engineer. I'm not really afraid of the times. I think there's going to be plenty of work, but I'll get into that in a little more detail, and I know some people will disagree with me on that front. Okay, my current view on a best practice for this, and this could change easily, is that what you should do is instruct your LLM to write a formal specification for whatever it is that you're trying to produce in terms of an algorithm, data structure, or architecture, review the output of that, and then tweak and enhance it in such a way that you then produce code. And then ultimately, later on, I think what we're going to find is that we get things like type systems to help us better understand the structure and the correctness of the code, that we can then write better and more functional tests, such as unit tests against this. So I had a slightly different view at the beginning of the semester on what I was going to instruct our students to do and how that would all work. I'm seeing some perplexed looks, so maybe I should go take a little bit of a step back in what these things are for maybe some of the people that aren't familiar. So we usually think of, we just produce code, C code, Rust code, JavaScript, whatever. And then we write a bunch of unit tests against that, and those unit tests have to be well-defined. The code itself has to be well-defined functionally so that we can write the unit tests against it. In order to provide these AIs or LLMs with context and providing them with a good understanding, we can enhance this whole process by doing things such as formal specification. Formal specifications is not a form of writing the code itself, but we produce a document and output. There's systems out there that will verify these. And basically what happens is that we can follow a more of a correct by construction paradigm. So when we have the formal specification and we match it up with the code, there's a one-to-one matching that we're getting exactly what we specified mathematically on the formal specification with the code that's being produced. That then in turn allows us to have better more functional and better unit tests, for example, that come out the other end so that when we have a defect in the code, we can be sure that that defect is going to be tested and covered, say, with our unit tests against the code base. There's these other systems that have been around for 30, 40 years called type systems. Anybody in here who's used something like JavaScript versus TypeScript know the formalisms that this brings about. And you're going from a duck-typed language to a strongly specified language. Dr. Kurtz is an expert in this particular area with category theory and such. And anyway, the type systems give us some new opportunities and attributes, which I'll get into in a little bit, of how to better construct our software engineering practices. And I think that this is a major opportunity, going back here to this previous slide, to improve these processes and relate some best practices that are out, get them out there into the general software engineering community. One of the other things that we've discovered, we are using that tool I mentioned, Aider, and we've been using, you have to use it with an OpenAI compatible API. So what that means is if you can use a variety of large language models against it, but the API that Aider uses underneath has to be compatible with the OpenAI one. And we have seen in just, gosh, I think it's been just the last 6 months, this transition from window sizes from 8,000 tokens in the window up to now currently 128,000 tokens in the window. Just to give you an example of why this is so important, one of the things my team was working on here just a couple of months ago was to port a large Scala code base. And one of the more interesting things about this is the engineers that are working for me did not even know Scala, nor did they really know Rust, because we're going from Scala code base to a Rust code base. So what we would do is pull in literally a few hundred files, and the AI would completely crash and wouldn't allow us to move any of these files with like the 8K window. Now with the 128K window, I can do the same thing with a few dozen or a few hundred Scala files and tell it literally to write my Rust code per the Scala implementation, which is all functionally programmed, and it comes up with all the same monads and monoids that are in the Scala programs and puts that out into a separate Rust file and does the for comprehensions and everything for us. It has been absolutely amazing, and we've seen just incredible differences by switching over the context window. Last week, we discovered this also with my students because we're using the new OpenAI preview, which has got the 128K size window. It's cheaper, it's faster, and now we're able to move through a lot more code as a result of using this. I guess one of the things I should mention there is that I was able, with the company that I'm currently working with, Firefly, they were willing to sponsor our class and pay for all the OpenAI credits this semester. So I've got a bunch of students that are going through several $100s a month of OpenAI service to help them with their assignments and such. The other thing that we have noticed with this is that the training cutoff dates really, really matter. Right now, that preview model I just mentioned, I think the cutoff date is March of this year. So we'll get into this in just a second, but there's been some code bases and some approaches that we just haven't been able to deal with using the large language models, such as Dino.js, if you're familiar with that framework. This is a relatively new system, a new subsystem. It's a play on Node.js if you have done any Node.js or JavaScript development. And anyway, the AIs, because the cutoff date with OpenAI was, I guess it was 2 years ago now, 21. Now it's moved up to March. it's amazing the difference that you can see with what these LLMs can actually do with the code base. So a lot of the work that, or I should say, part of the art that we have discovered in doing this is to figure out how to use these LLMs, and I'll give you a brief demo with Aider here so you can get a sense of it. But you have to really maintain context with the code base. And that's a constant job that is that's really the software developer's duty, this part. The other thing that's interesting with the most recent preview model is that you can actually begin leveraging the documentation. So one of the things I did recently here with some Rust code was I actually did what's called a cargo doc, which documents the Rust code and the current dependency graph and the code base, and spits it out to some HTML. I'm actually able to use that and import it now into Aider and into the AI, so that it has the documentation around an API set to a library, for example, which is just amazing in my mind. I just discovered this the other day. So now we're able to work much more effectively with these things, and figuring out all the tricks of the trade and in managing and maintaining that context is key. That's not to say that there aren't some glaring deficiencies with this too. One of the big ones that we've discovered is that it simply gets things wrong, and I'll take you through an example of how badly it can get things wrong and how you still have to be an expert in many of these spaces in order to effectively use these things. Not to say that they're not useful, but you've got to be very careful. So I know Dr. Vivek, I didn't see him here at the ACM meeting, but I saw him earlier this year at one of the Java meetings from Google, has spoken about this at some previous talks. Maybe he talked about this in July. But there's big concerns, especially amongst the big tech companies, that they can't use these tools because they're trained on open source code. They're afraid of getting sued. So these big tech companies like the FANGs, they want to have specialized code bases that they internally train and then use under a domain-specific approach. So they'll take and train their code inside these big corporations, and they'll sequester their engineering. There's opportunities maybe for improved efficiency, but there's also some big questions about whether these things will actually improve efficiency as you get out to the open internet. So open source is the counterexample to this, and there's a whole bunch of effort and initiatives in this space, or in the open source area, that are trying to figure out how we can most effectively train code bases on the open source model, or the open source systems. And I think we're going to see a push there toward doing source code sequestration too. I know of some people in the Bitcoin space, which I'll talk about in just a second, that are actively putting forward these approaches where they're going to actually take the source code and keep it independent and off the open internet. You're only going to get access to it if you use their AI that's been trained on. So you still get open source code, but you don't actually get it necessarily out in the open. So when I first started the semester, I thought, okay, we could probably create a domain-specific AI, because there was these things, and I'll get into it in just a second, called vector databases and such, that you could actually supplement or enhance the LLM with your own training. That has turned out to be much more difficult than I ever thought would be, especially with tools like Aider. So, and it's also getting more interesting, especially with OpenAI's announcement last week. So this was our original idea at the beginning of the semester for what we were going to do. Basically, we have the applications that we want to build that are there on the right side. There's something called Nostr, which is a Bitcoin protocol and framework for communication. So it's actually just a protocol. It's not an app itself, but you can write what's called Nostr apps, which use the underlying protocol that will discover and communicate with other peers on the network. The idea behind that is to create a Bitcoin-based, well, it's not necessarily Bitcoin, but just create a decentralized social network. to move away from all the problems that we're seeing with Web 2 and such. And then we were going to use something called Fresh.js, which is built on top of Dino, which was then going to use for immutable services, was going to use something called RGB, which is really good Bitcoin. RGB is a very interesting framework. It's developed, it comes out of a lot of early Bitcoin research and work by a guy named Peter Todd and Maxim Orlovsky, who's the primary creator. And essentially, I describe it as a peer-clique system. So you can create a set of isolated networks where people are talking and interacting with one another with smart contracts that are running in people's wallets, not actually on a blockchain. So this creates a very highly scalable system. And then what we were going to do is take some exemplary code. We're going to be producing code on that side of this, feeding it into the LLM so that it could then create different monetizable components that could be used by the LLMs. Now, this turned out to be very, very challenging to do for a couple of reasons. One, there's a lot of work that has to go into building these things like pinecone vector databases that would supplement the LLM. The other big problem is, or that other thing that would have made it a lot easier, is if OpenAI had actually provided us with an enterprise account. And I have not been able to get them to even reply to me through their sales team. The enterprise accounts allows you to create domain-specific AIs that you can readily enhance and that are kept private to just your organization. So that hasn't worked. So unfortunately, we're doing a portion of this now at the end of the semester with our final project. But the idea was essentially to create this virtuous cycle whereby the AI would get trained, that would produce better code, and then that could be then used as a service to then help the software engineers to write even better code as a result. So we get this cycle in which it's a reinforcement loop in which we get more code produced faster and better trained from the code that we've previously written. So this was the basic idea. Where I'll get to where we're actually going to wind up with our final projects this semester. But this notion, I think, was also 6 months ago or so. There was a lot of other people that were thinking the same sort of thing, because what we can do is make AI as a service for the software engineering community itself, and that's what this would have ultimately done. So in my class, what we're doing is requiring all students to use the AI to write their code and do their assignments. And if you talk to me, gosh, at the beginning of the summer before this class was going, I was thinking that we'd do just a straight up, it was going to be focused on concurrent smart contracts with Bitcoin. But it became so apparent with my team as we're doing our software work that we were much more productive. We're actually much more satisfied with the code we were writing and such, so that by the middle of the summer, I thought I'd be doing a terrible disservice with the students at Chapman if I didn't introduce and require them to use AI to do the work, because this is fundamentally going to change the way people write code, I think, in the future, and we need to get on top of it. So the students are required to do git commits of all their interactions with the AI, so that what that means is that we can see in the logs exactly how they prompted the AI, and then what they instructed it to do, and then see what the resulting code is that comes out with a pull request. We also set up consistent development environments to use that, and then there's a continuous integration feed that we set up on Discord, so we can see as students commit and create these things. So because we didn't quite make that original stack, I think it was overly ambitious with what I showed you on the previous slide. What we have decided to do is to create one single final project for the class. And what we're doing is breaking up the class into different groups, doing design, doing user interface, doing back-end services, doing smart contracts. And the students had a choice of 4 different apps that they wanted to write, and they've chosen to do a Bitcoin dating DApp. So I should have guessed that this would probably be happen. I had an opportunity to write a Balboa Ferry app. I happen to know the owner of the Balboa Ferry, and he's in need of having an app that had some advertising, and he's trying to go green with the ferry. And so I had that on the list. I had another social group that I participate in and was going to have them do that. But I could tell just by the light in their eyes yesterday when they voted on this that they're really enthusiastic about this particular approach. Now, what does this actually mean to write a Bitcoin DApp or a Bitcoin dating DApp as opposed to a traditional dating DApp? So most of you, I'm currently single. Most of you probably, if you've done any of these dating apps, you're probably frustrated as can be, as I've been. I refuse to use them anymore. But if you take something like Tinder or Bumble or one of those others that are out there, we can think through this by just looking at the transition between what's known as Web 2 and Web 3. Web 2 is the traditional way that we think of apps as having been developed over the years, over the last 15 years or so, I guess, since the iPhone came out. And typically what you do is you'll write your code in something like Swift or Kotlin or React Native. You'll take a hosted service like a cloud provider such as Amazon or Google or Microsoft, and you'd have all your backend services running there. Meanwhile, on the front end, you just run something like React primarily to get the app working. With a Web 3 approach, it's completely different. Well, I shouldn't say completely, but it's very different. So one of the big changes coming from the top down is you can do these things called progressive web apps. Progressive web apps, or PWAs, are apps that you can install that you can basically ensure that there's censorship resistance against them. So you don't have to go through Apple's App Store, you don't have to go through the Google Play Store, you just hit the website and you basically create the equivalent of a bookmark that's on your phone or even on your computer. So that bypasses the censorship issues that we've seen in the app stores and such. You can also make these things so they work across tablet, mobile, and computer. And then we can think of this as essentially there being fog services out there as opposed to cloud services for these things as they're being developed. So you can take a much more granular approach with the individual services that are being used by these DApps as opposed to apps. And what this means is you can do some really interesting and different things. So in the context of a dating DApp, you could, for example, set it up using like a zero-knowledge proof system so that when two parties that might want to match are within the same geographic vicinity, they can find one another without revealing their location. So there's a whole bunch of benefits. The other thing you can do is you can keep the data completely sovereign. So the data is sitting on that on the individual's device in a distributed system, a distributed file system, essentially. And everybody gets to hold on and retain their data. There's no central authority that's doing big data analysis, algorithmic analysis on everything that's produced. So so rather in the Web 2 context, if it's free, you are the product. In the Web 3 context, if it's free, you're part of the community. Because you're as a builder or as a user in the Web 3 space, this gives you the ability to participate in new reward models, typically done through things like tokenization. So coming back to this, what we're wanting to do with this dating DApp is to create a reward system with Lightning Bitcoin, so people can manage their reputations and they'll get more Bitcoin. If they have bad behaviors, then they can get demerited, if so to speak, and lose that reputation. And this is actually kind of part and parcel of the whole Bitcoin ethos and what you're seeing with the development of decentralized applications. Okay, so I'll give you guys a brief demo, and then I'll take only about 10 more minutes here. I've already told you about porting Scala to Rust, and this is what Aider looks like. Okay, I'm in that actual repo that we've been working on. I'm going to start up Aider on my... Oh, yeah. Thanks, Alexander. Good point. Okay, I'm demoing here is a Python tool called Aider. It's under Paul Gauthier /Aider on GitHub. You can install it pretty simply with if you have Python installed, just like this. Oh, and by the way, what I'm using here is an AI terminal called Warp on Mac. And so what this actually allows you to do is to ask Warp AI. I'll do it this way. You can actually interact with the AI as you're developing things in your terminal. I assume I'm a big command line guy, and I assume people who are doing development these days would prefer to probably use visual tools and things like VS Code. But I'm finding that to be more effective with using these AIs, you really need to go back to the command line, because you've got a history of everything that you've executed. You know how it's, what's been run when. I have like an eternal history in here, so I can go do things like this. Show every time I've run pip and install, and it goes back 10, 12 years of all the commands I've ever run. But anyway, as I run this, I can then actually come over here and ask the AI itself. So, and it correctly identified. You guys probably can't see that. I don't know if I can increase that font. Okay, so with Aider, what I just told this to do is to bring in this file here, this authkey.row. This is a language called, this is called Rowlang. This is one of the other things that we've been working on, is to use a new process calculi called row. Early computer science students will probably all know Alan Turing and Alonzo Church, who came up with the lambda calculus and the Turing machine, etc. This is a way to do concurrent programming with this language. And so I'm going to test you live. I actually haven't tested it lately on row code. And you can actually interact with this directly, just like this. And then there's a complete log that's kept of... Uh-oh. Oh, my demo for the day barfed. I don't have time to go put more credits up on OpenAI. But that message says you are out of credits. I apologize. I was hoping to give you a more interesting view of this. But yeah, so like I said, I think earlier, my students, I think we're burning through about $600 a month in OpenAI credits with a class of 18 students, and then I've got a couple of individuals that work with me too. So this stuff is not cheap, but we're finding that it's very, very well worth it. Okay, I apologize. We got probably students actively working right now, burning those credits up, and I've got to put more in the morning. Okay, but yeah, this should have properly described this Rowlang code. And let me just... It's a pretty simple example. It was just bringing in a new... it's inserting this SecP256K1 key into the row registry. That's all it should have actually told me. So I wish I could have shown that to you. Anyway, We'll go and dig a little bit deeper here. So I gave you the example of moving from Scala to Rust. Literally, we're reporting, I think it's about 2,000 lines of code with engineers who know neither Rust nor Scala. One thing I'm finding with the engineering teams is that there's no longer an excuse not to write unit tests. Because if you've got properly written code and it follows that path I was describing earlier, with functional specifications to the end at writing unit tests, you can literally pretty much tell the AIs these today, and it does all the boilerplate work for you. I mean, that's one of the things I always found it to be a pain writing unit tests, was doing all that boilerplate work, and it's all set up and structured. The other example I'll give you very quickly is I had Greg, who is the guy who runs Firefly, send me his chat log session with Aider, or actually this was actually with OpenAI with ChatGPT, and he's working on, let me see if I can increase that font. Oh, it's not allowing me to do that. Let me see if I can bring it up here. That's probably more readable. So Greg is a pretty sophisticated mathematician who's well known in the communities because he's the developer of the Rho calculus and the Rho language itself, which is a blockchain programming, smart contract programming language. And he's working on something called hyperdimensional computing currently. And he was kind of blown away the other day when he interacted with the AI to produce something that's completely new and novel. Those of you who may not be familiar with hyperdimensional computing, or HDC, is basically, the way I think of it, is it's a system that allows you to create these fuzzy associative memories that have more deterministic outputs, so that it could actually really change the way that we do AI with these systems. And he was implementing on this thing, in this algebra the other day, the system here, this approach here, where he had to use something called Lamer codes with some permutations, and he asked the AI to write the algorithm for him. And you can see that he interacts with this, and these are the user prompts. And as we get down here, and he notes that there's a factorial calculation that the code that's returned uses, and he wants it to actually pull something in called a Lamer polynomial code. Anyway, to make a long story short, because I know we're running out of time here, he was able in 5 prompts to have have ChatGPT write a very sophisticated set of algorithms for basically a set of vector operations in under 20 minutes. He said that this would have taken him a couple of weeks to do previously. But he's an expert, and in this context, you have to be an expert to actually be capable of reviewing the output of these things. So it's not a magic bullet by any means. Okay, I've already mentioned programming languages. We've used it in class to actually help us develop UIs, develop designs. One of the most interesting things we did yesterday was to define an MVP, a minimum viable product, a mission, and a community for this. Okay, I'll wrap up here in just a minute. Here's the implications that I see, and this is a laundry list of them. In particular, what are we going to see with open source licenses? Can proprietary source actually keep up once all this code gets out onto the open internet? How can we sequester this work, as I mentioned earlier? What's the best way to get high quality code output that can be better written than human code, which I gave you one process that I'm thinking about. And I think one of the big questions, I'll skip over some of these, is what are the ethics behind this? One of the most interesting things to me is that if you've got AI producing code, AI either makes a mistake or does something differently than a human might, because they might be ethically oriented toward, I don't know, a different focus on safety for an end user on a train track or something like that. Who's responsible? How do we ensure that it's properly done? The other thing I'm seeing is that, and Dr. Kurtz and I constantly are talking about this after we get done with these classes with the students, we really have to change the way that we train or that we teach computer science, I think, as a result of these things. I'm finding that it's much more important to understand data structures and algorithms and technical architectures. And we probably wouldn't emphasize that, especially with some junior developers or some early students like we did before, because you don't have to teach them a language. We typically go in and focus on a particular programming language, and instead now we can get more abstract with a lot of our teaching. And also, interestingly enough, we can ask the students themselves to figure out how to interact with the AI so that they can become self-taught. You know, they can create their own lesson plans, so to speak, by just interacting with the AI. Like I said, there's no need for learning programming languages, but there is a critical need to teach people to be more discerning and judgmental about the output of these things, because a lot of times we just want to take whatever comes out. The big opportunities that I see, especially maybe in the next 6 months to a year, is that we're going to get more automated software reviews. You know, I could easily imagine an AI doing your pull request, your code review, before you merge it, and coming up with probably some better critiques than a human typically would. And the other thing that I'm reading about a bunch in the venture capital space and in Silicon Valley is how this is going to be applied to DevOps and continuous integration systems. These are almost certainly going to completely change. You know, we've relied on things like microservices and Docker up till this point. I suspect that we'll have AIs doing mass coordination in either those cloud-based systems like I was talking about with Web 2 or with Web 3, these new fog-based systems that are emerging. I get questions from the students quite frequently, well, things are really changing, I'm in my last year, what should I do? The thing I'm emphasizing with them is they need to be self-starters and they have to be continuously learning and learn how to interact with the AI itself. One of the things that I haven't done too successfully this semester, but I know Dr. Kurtz has done some good work with his classes, is to create gamified approaches. If you can keep students interacting and feeling like they're part of playing a game and learning and using the AI or learning the concepts, that's actually really key. I also personally wonder if we're not going to see a bifurcation in skill sets. So that, are we going to see junior engineers turn into 10x engineers, or is it going to be the other way around? Are we going to see that the senior engineers just become so much more productive because they're much more effective with these AI tools that they far and away surpass the productivity and quality that's produced, and you can do it with fewer people? I know one of the podcasts that I listen to frequently is called the All In Podcast, which is a set of VCs out of Silicon Valley or former Silicon Valley VCs, and they're constantly saying how they're going to be able to scale down these startups. Rather than providing a startup, say, with $500,000 in seed funding, now just a couple of people can go off with $100,000 and build something, a minimum viable product that will in turn produce a lot of revenue. In fact, there was I think he was a high school student recently this last summer who produced a full-blown app with just the AI, and he got VC funding immediately to the tune of several $1 million. The other thing we're noticing is that verbal skills and communication skills, people's actual level of articulateness is important, because you're not able to interact with the AI unless you can fully describe what it is that you want it to do. And so I'm wondering if the communication skills won't become more important as we move forward. And then collaboration amongst the team members becomes even more critical. I won't go through this because we're running out of time, but as I mentioned earlier, there's a whole bunch of old technologies that I think can be applied to working with AI. And I think this is an area that I personally want to get more involved with because the impact on software engineering is just going to be fundamentally different. Okay, just to wind up, AI is here to stay. It's not going away. It's going to be used in coding. I don't think that we're going to see a reduction at all, especially over this next year. I do think it's going to have a huge impact on the balance between proprietary and open source. What is going to have the stronger ecosystem? It's also going to have a huge impact on your software engineering workflows, processes, and team practices. As Mark Andreessen said in his famous essay from about 10 years ago, Software Eats the World, humanity needs more high-quality code and a greater degree of automation. So all this means really is that there's more opportunity. It's like the standard bearer in some economic models where the cheaper something is to produce, the greater the demand that there ultimately is for it. And that's the point that he makes. And I'm sure you guys have some questions.
You're dealing with, I mean, you mentioned you're dealing with students in their last year, right?
Primarily, yeah. They're mostly juniors and seniors.
And, you know, I'll bet that the software engineers that you had translating Scala into Rust knew some other programming languages. They might not know Scala or Rust, but
my most junior engineer does not have a computer science degree. It doesn't have a 4-year degree. I basically have been teaching him over the last couple of years.
I guess my real question is, what do you think about students who are coming out of high school, who've never written a line of code in their life, and are put into a course where they're learning Python for the first time? Should they learn Python before they dive into using AI, or
I think ideally, I think these systems are so powerful, they should go to the AI and say, give me a Python learning lesson plan, and follow through with that if they want to learn the language in more detail. But one of the things we're discovering is that like Aider is so good that we can give it a piece of Python code, Scala code, etc. And as long as you understand most of the core computer science concepts.
How do they learn core computer science concepts?
Exactly. That, I think, is the primary question. I think that's where we need to...
You imagine there's kind of a language-free computer science concept?
I'm imagining that we're going to change the way Dr. Kurtz and I talk about this like constantly after every class. We're trying to figure out how it is that we want to... How would you change the curriculum in the context of AI? And I think that we might need to go back to, there was a famous book when I was in school called Data Structures plus Algorithms equals Programs. And that was something that you typically didn't read until your senior year or maybe your junior year. You may not get to that until later. I think we need to be able to shift that and invert it and bring a lot of that stuff up front. And it's like Dr. Kurtz also likes to say, we can now be much more abstract and theoretical in a lot of our teaching. In fact, I dug into functional programming and monoids and monads with my class this semester. Normally, I wouldn't touch that with a 10-foot pole, even with juniors and seniors. Because you can just go really deep. But now with the AI, it can actually explain to you these concepts and whether you've written a proper monadic element or a monoidal structure in your code base. And we discovered this kind of by accident in our group, porting that Scala code over that I mentioned earlier.
So we used to teach programming, a programming language like Python, right? And then for the students to do the exercise, they needed to develop problem-solving skills.
Yeah.
That's not the case anymore, right? So we can insist on continuing to teach, say, Python, but students will not learn problem-solving on the way. if they use AI, which we cannot prevent them from doing. So if we want to teach them problem solving, which is what we want to teach ultimately, we need a completely new way of doing that. And I'm not saying that this will be the solution, but that's something that Jeff and I are talking about, is we could teach them theory. And then they would implement the theory into running programs using AI. They don't need to know Python to write a running Python program. But the problem solving we teach them is not writing code, but kind of at least one level of abstraction higher up.
So basically teaching them to do mathematics.
Yeah.
Yeah,
exactly.
I think we have to become much more mathematically oriented in our teaching too.
Can I comment on that as well?
Yeah.
For some time, I think it's been the reality that writing code is not a value add proposition. So, yes, you have to write code to solve problems. You've had to do it, but it's certainly not an economic value add. With outsourcing, it was very clear that this is not where you want to stake your value to an employer. And with technologies like we're seeing here, definitely not. So your value add with a computer science degree and an engineering degree ought to be solving problems. And how you teach people to do that is certainly an interesting problem. And on the programming side, the dark ages, long ago, probably in the late 70s, I took a programming class that was taught. It was probably an advanced programming class. So people had some problem-solving skills, but it was a 10-week class, and we had 10 problems, and we were given probably 10 different programming languages. And you pick a programming language for your problem. So being adept at going from one programming language to another is something that you would expect someone who's proficient at solving problems to be able to do.
Yeah.
This question is on Aider. Can Aider be used to transcompile older legacy language like COBOL and convert into Rust? Because there's a lot of code base which is sitting on the legacy system.
I haven't. So the question is, can we take like legacy code such as COBOL and convert that to Rust? I haven't done that personally. I would assume that it would be pretty straightforward. It's a matter, like with the Scala code I was mentioning, it's a matter of pulling in the files that you want to have translated, and then what I typically do is have it describe what the functions are in the file, what the data structures are in the file. And I say, well, you write a Rust scaffold for this file. It creates the .rs file. I don't see any reason why you couldn't do the same thing with COBOL. Although COBOL, I used to be a COBOL programmer ages ago in college. That's probably got a very different, what do I want to say? The imperative structure there, I think, is going to be maybe a bit more difficult for some of these LLMs to handle. But I don't know. It's worth a try.
Sure, thank you.
As you said, that the automated reviews will be like the next 6 or 10 years, like they will be like all using the AI to doing the code reviews before commit, right? So, what if the code is already is also generated by AI, and then we use AI to do the code review? Will it be like more stochastic?
Yeah. So the question is, when we get to a process automation where the AI is actually generating the code, and then it's asking it to be reviewed, how is that all going to, I guess, basically work? Now, one of the interesting things that we've noticed in using this over the last year or so, or 8 months or so, is that, such as that example with Greg Meredith writing the permutations with that vector algebra, he simply just had to ask the AI the right questions, and it would then produce proper code. So going through that iterative cycle sometimes gives you what you need as a result, but you still have to have that judgment and discernment on what's coming out. I don't see humans, but there might be some differences in view. I'm sure there's people who work for big companies already using these domain-specific AIs for their coding. There might be different approaches that are being implemented as software engineering practices in those kinds of companies. I really doubt that humans will ever be completely out of the loop on these things.
Yeah.
let's get more questions. I don't
Okay.
know.
Oh, okay.
Yeah, actually, I use this workflow before. I just like using AI to generate code and then doing AI to like do the code review. And like the problem is that when I do like this loop, and sometimes the problem seems to be more and more difficult to be debugged.
That can be true too. The problems can get more difficult to debug because, and that's one of the reasons I prefer Aider over some of the other tools, is because what it's actually doing is creating Git commits, so you can always backtrack. If you get taken down a rabbit hole, it's fairly, if you know Git well enough, it's fairly easy to come back up out of that rabbit hole and go down a different path in using the AI.
Thank you.
Yeah, hi. Excellent talk, I thought. I have a question basically
Thanks.
from your experience with your non-student people who are working with this, right? Your engineers and stuff like that. So I work at a small startup company, and obviously I think there's some wariness when it comes to software engineering teams who like know that AI is changing the game, but haven't been able to or aren't willing to make the commit where, hey, we're going to allow access to the OpenAI models to access our code, right? Because I know they can train the models and all that, you can turn that off, but you still have to send the request with the context window
Right.
containing the stuff to the OpenAI API, and during that little fraction of time, right, that IP is no longer in your possession.
Right.
So I would love to hear your perspective on that.
I meant to bring this up in more detail. So the question is, there's some hesitancy about using these AIs because you're giving up potentially proprietary code to the LLM to train the LLM, and I'm in a privileged position in that I work on just open source technology, so we don't worry about any of that. And that's a luxury that we have, and I recognize that that's probably not typically true in a small software company or some of the larger companies. I know we've heard previously about how like companies such as Google are building their own internal systems that don't give up that information. I do think there's an opportunity with blockchain tech to sequester the training data and then keep it on the side and then create these federated AIs. I hope and suspect that we'll see that in the open source community over the next few years. Because you can easily imagine changing the open source licenses or open source licensing practices so that when you use it, you have to maybe use an AI as your coding assistant that's part of the open source project or part of the open source ecosystem. Because there's going to be a push, I think, especially with companies like OpenAI and Google and such, to keep them from learning about all this open source code, and then maybe small companies that have proprietary code can leverage that too. Anyway, that's just my thinking at the moment. I don't know where all this is going to go. None of us do.
I actually have a follow-up on that. So I have the same problem where, like, I have proprietary information. How do you basically come up with fake variables and fake data and fake databases and stuff like that so you can then put it in to, say, OpenAI and not have to worry about going against their IP?
Okay, so how do you set up a system to keep your proprietary information to yourself without giving it up to somebody like OpenAI? I would have 6 months ago, I would have said, okay, we're going to use something like Pinecone, do our own embeddings, have a supplementary LLM that would work in addition to OpenAI to do that. Then OpenAI announces their enterprise version, which they supposedly, and I think it's probably accurate, they'll keep all that information locked up and secure and sequestered from anybody else's use. So you can get a license there. Like I said earlier, I haven't been able to get even a hold of OpenAI's sales team to help us out. So I hope and suspect, going back to the earlier question, that we'll see these sequestered data systems emerge as a mechanism, probably first to protect open source projects, but then eventually support other proprietary source projects that are probably among small companies and then larger companies. That's just the way, just talking to people, and it happens to be a guy in the Bitcoin community who developed the really good Bitcoin protocol, Maxim Orlovsky. And he and I have talked about this a fair amount, and he's already moving down that path to try to create these systems to do exactly that. So you can sequester the data, have it isolated into some federated learning models, then he's got a whole game theoretic approach actually using Bitcoin for the payment infrastructure.
So what about doing it on the cheap? What if you can't pay for that stuff?
Then I think you got to code it yourself. But the good news there is that you're becoming that much more productive writing this code, right? Yeah. I think there's a question, yeah.
Thanks for the great talk. When it comes to teaching, especially things like Intro to Programming, CS 101, I think there's a bit of a catch-22 in that you need to understand enough to know when the LLM is telling you incorrect things.
Yes, exactly.
And so I'm curious to get your thoughts on, while in this advanced course, I think you totally did the right thing by fully embracing the tool and saying you're required to use AI. Like, how do you think that would translate to a CS 101? I think of this interesting analogy. The FAA recommends that pilots turn off autopilot when possible,
Right.
so that they don't forget how to fly.
Right.
Do you think there might be some pedagogical value to having a small fraction of your teaching days be AI free?
In my particular class this semester, I don't think our emphasis is actually on using these LLMs to help us with the coding, but I think you're exactly right. How do you get enough of a knowledge base for students, especially in a 101 type class, so that they know that the AI is spitting out garbage to them? Teaching that discernment and judgment, as I call it, is going to be key. I think, I'm hoping, per what I wrote up there with the notion of, I think this was originated actually by Dan Bonet, with that notion of doing formal specification, followed by reviewing that specification, then ultimately producing the code from that. If we can get students to use more of those abstract techniques and know what they're doing with those tools, I think we can probably have a much more effective teaching strategy with them as well. So, but I fully agree that it's an art right now figuring out how much information they have to have in order to exercise that judgment. Yeah, and my slides have some of the links and resources if you have interest.
And we have something for you, a couple things for you, Jeff. Just as a token of appreciation, we have a little certificate thanking you for speaking.
Oh, thank you.
And if you're a coffee drinker, we
Oh, yeah.
we have a little thing that you can also use to get some coffee.
Thank you so much, Dan.
You're welcome.
Now I just need to get ACM to accept Bitcoin.